Welcome and hello. This is a video tutorial in hEC-RAS, and in this lesson, I'm going to be talking about geometric data, specifically storage areas and 2D flow areas. All right, what I have on the screen here is my hEC-RAS. Got the main file GUI at the top, and then the geometric data I've got opened up down below here with a couple storage areas and one 2D flow area. Storage areas and 2D flow areas are two ways for water to be stored outside of the river or the channel in hEC-RAS. Both can be located at the beginning of the reach, the end of the reach, or off to the side. So right now I don't have any reaches even in the map, but if you're going to go ahead and create a storage area or a 2D flow area, you go ahead and click these buttons here, sketch it out, give it a name, and then once you're ready to edit the storage areas or 2D flow areas, you go ahead and click the button down here on the editor's column of buttons, storage area and 2D flow area. Let's go ahead and add another storage area. So I'll click on storage area. I'm just going to go ahead and click and double click when you're finally finished. Storage area 3. Okay, that looks fine. Storage areas I like to think of as ponds or lakes, detention areas, and then 2D flow areas, typically more of like a floodplain area, but it kind of depends on what your model is, how it's being used. Let's go ahead and create a 2D flow area. It's basically the same process. I'll click on add the button here for add new 2D flow area, and then I'll start sketching. Single left clicks to begin, and then also single left click to add a vertex. Also worth mentioning is if you're going off to the side of the screen, you can like right click and that will recenter your view on the cursor. So if I right click here, it recenters me. If I right click down here, it recenters me again. Just a helpful tip there. Okay, so I'm just going to go ahead and just complete this as it is. Double click to complete. I'll call this 2D flow area 2. Okay, and let's make one more 2D flow area, maybe right over here. And double click 2D flow area 3. Storage areas and 2D flow areas can be connected to a river reach using a lateral structure connection. Storage areas can be connected to other storage areas by using a storage area connection. We can also delete the storage areas and 2D flow areas by just single left click, and then I can edit right here, but I talked about delete, so let's do that. Click, and then delete storage area, and then poof, it's gone. Same thing with the 2D flow area. Goodbye. Yes to confirm. All right, let's go ahead and draw that storage area back in. Now, typically, you're not going to call these features storage area 1 and so on, 2 and 3. You're probably going to call it Folsom Lake, YOLO Bypass. They will have names, but for the sake of this exercise, I'm going to just name them by the type of structure that they are. All right, you can edit the storage area by just single left click and then edit storage area. I've got some numbers already in place right here, as you can see, elevation versus volume. This is one of two ways to define the geometry of that storage area. And then the other option here is area times depth method, which just assumes a constant area for all the different elevations. So if I said it was like 100 acres at a minimum elevation of 613, and then the other option down here is elevation versus volume, where I have a minimum elevation of 613 again. However, the volume increases in a nonlinear fashion. So if I click the plot here, there's a plot volume versus elevation. We see the two different options here. So this blue line, the straight line, that's just your standard area times depth method right here. And then a more normal, natural looking pond or storage area is this one right here that has these points in this curvature. All right, so I can close that. We can also edit the geometry of the other storage areas just by selecting them here. We can also toggle through the storage areas using these up and down arrows. There's also a button here to convert the storage area to a 2D flow area. Actually, let's go ahead and click that button just to see what happens. So I'll click 2D flow area. It's asking me, am I sure I want to convert the storage area to a 2D flow area? I say yes, and then that change has been made. Now, I'm not seeing the updated colors here in the GUI of the geometric data editor yet, but I will. And then this is the edit screen for that 2D flow area. Even though it says storage area 1, it really is a 2D flow area now. So that's what I mean when I say you're gonna name it with whatever it is its name, not by its type. But if I click OK now, yeah, so it turned into this light green color because that's the color my symbology is set up for 2D flow areas. And it looks like the buttons are also using that same default coloring. Okay, so let me go ahead and switch that back. I can click and then edit 2D flow area. And then there's a button here that says convert to storage area. I'll say yes. Am I sure? Yes. And look at that. It preserved my same geometry of the storage area. So if I click OK, then we're back to where we started. Great. It was covered in another earlier lesson, but I should probably just mention that if you wanted to modify shape of your storage area, you can go up to Edit toolbar and then click on Move Points or Objects. And now you can move all the vertex points for that storage area or the 2D flow area. Also, if you wanted to add a point, then you can go Edit, Add a point. Say we wanted to add a point right there, no problem. Now we can click on Move Point to give that some a different shape, and that's how that works. Okay. We can also delete points. Say we wanted to delete this point right here. That's fine. And then we can also change the name. So for instance, if I change this storage area to a 2D flow area, I may want to change the name to something more appropriate than storage area. All right. I'm going to click this remove points once again to make it unchecked. Therefore, I'm no longer editing. And then I can, yeah, delete storage area and 2D flow areas using this interface as well, in addition to just clicking on it and clicking delete. Now let's focus on the 2D flow areas. We have two 2D flow areas I have sketched in right now. With 2D flow areas, the user must define the computational mesh, either structured or unstructured. As with storage areas, you saw how we created a new 2D flow area just by sketching it out here on the map. Now, oftentimes you may have some background imagery that you have loaded up into the geometric data. And when that's the case, it may be easier to zoom in and then get an exact match or a more closely drawn, a more accurate drawn 2D flow area or storage area of the actual structure in your geometry. So background maps as well as terrain data, which can be loaded in using the RAS mapper tools. But as for this exercise, I'm just sketching in these storage areas and 2D flow areas just on my map as it is. I'm going to zoom in a little bit here on the 2D flow areas. How about this first one here? Before we add a computational mesh, we can add a break line. In fact, let's go ahead and add the mesh first, and then I'll add a break line and then recompute the mesh so you can see the effect that that break line has in the mesh computation. So to make edits, I'm going to come over here to 2D flow area, click that button right there. Now we can use this editor here to toggle through the 3 different 2D flow areas. Let's focus on this one right here. We've already seen how to convert it to a storage area. That was fun. Now what we're going to do is click this button to generate computation points on regular interval with all break lines. Now we don't have any break line yet, but that's fine, but we're going to generate the computation points and generate the mesh. So if I click this button, it's now asking me the spacing for the dx and dy for the mesh that we're going to create, as well as an option here to shift the generated points. This allows the user to change the coordinates of the cell center in the mesh. Okay, so I'm not going to do that, but I do need to specify a dx, dy. And before I can do that, I'm going to go just measure. So I'm going to hold down Control and then just single left click. And it looks like that's 0.34. Okay, and then let me close that. And then across is probably about the same distance, 0.31. Okay. So if I open up that 2D flow area editor again, generate computation points, maybe like a 0.05, 0.05. Oops, I got the wrong one selected. I got to select flow area 1. There we go. Generate computation points. And then I'm going to say 0.05, 0.05. Let's see what happens with that. Now, this is not the scale. I'm never going to have a flow area that's that small, but I was too zoomed in when I actually started my drawing. So it's all good. It'll work just as well. So I'll click on this generate points in a 2D flow area. There were 31 cells that were created. We can't see them quite yet because this geometric data GUI hasn't updated, but if I click OK, now I do see the 31 different individual cells for that mesh that was just created. So if I zoom in here, I can see the cells a little bit better. All right, I'm going to click on that 2D flow area, and then right here, there's a button that says View and Edit the Computation Points. Oops. Again, I've selected the wrong flow area. Let me go back up to 1. There we go. View, Edit the Computation Points. And these are the 31 different cell centers, I believe, for the 31 different cells that were generated. There is a nominal size to these cells, which I believe is the size of these square cells in the center. But cells that are along the boundary or some curved region are going to be a little bit larger than the nominal size. Okay, let's go ahead and back out and then add a boundary or a break line, they're called. So we'll click OK. There's this button here that says 2D area break line. So I'll click on that. And I'll zoom in a little bit. And disregarding the existing grid, say for instance that you have an area that you want to prevent flow or discourage flow. That's where we'll create this 2D area break line. And what's going to happen is I'll draw the break line. How about I'll just draw it on the interior? I'll draw it here, and it'll basically kind of mimic the edge for this left half, and then double click. That's going to end it. So I'll give the break line a name. I'll just call it break line 1 so we remember what it is as we're just learning this, and I'll click OK. So I have this break line 1. Oops, I clicked on the 2D storage area. If I click on the break line 1, there we go. Now we can edit the break line data right here. This is just the XY coordinates, so there's not a whole lot there. But now what I'm going to do is regenerate the mesh for this 2D flow area. And you're going to see that the cells that are generated will use this break line as a barrier or a boundary, which will later be used by hEC-RAS in simulations to prevent flow. Now, break lines are optional, but they should be added to enforce a barrier to flow. Okay, so let's go back and click on 2D flow area and then generate computation points. I'm going to use the same size for dx dy so we can see how that changes, and then generate, and then yes, and click OK. Now you can see what happened here. The cells sort of readjusted based on that break line. Now, some of the cells sort of in the right half of the 2D flow area looks the same, but in the left half, it took into account that break line big time. Okay, let's go ahead and go back to the 2D flow area. We have a number of other parameters here, such as the default Manning's end value. So you can use the default to 0.06 or type it in, whatever it is. You can also edit land cover to Manning's end. This is basically a mapping between land cover and Manning's end. So if you had a land cover layer added in, and I don't have that right now, but if I did, and then I had some values here for Manning's end and land cover, then that correlation, that roughness for Manning's end could be determined based on the land cover. The next few fields are related to tolerance, such as cell volume filter, cell minimum surface area, face profile filter. Whenever you see this TOL, that refers to tolerance. It's used to reduce the number of points in the 2D grid as a way of saving processing time. So these tolerance values can be adjusted as a way to balance between accuracy and processing time. That's controlled using these tolerance values. Typically, you want larger cell sizes if there's less detail, there's less change in slope, whether you're talking about topography or in this case, water surface. But if there is a steep gradation change, such as in water surface, then you're more likely going to want to have smaller cell sizes. So you can model the difference between adjacent cells for each time step of the simulation. The user manual describes this in more detail. All right, there's a few other values here like face laminar depth right here. Now, 0 means it's off. Otherwise, it's in feet. The default values are shown all right here. So 0.2 feet is the default value. This refers to the depth of water at which turbulent flow would transition to laminar flow. Another image from the user's manual is shown here. This is a 2D flow area that's been generated, and you can see the cells. This looks like the river right here, or the channel, and then there's a break line that was drawn in right here. It's an entire polygon, and you can see that the cell size is much smaller in certain areas, like around the break line specifically, but also the channel. And then the cell sizes are much larger way out here in the floodplains, where there's expected to be less turbulence, less change in water surface elevation. Next, the user manual talks about the mesh properties, specifically cell center, cell face, and cell face points. The cell center right here is the individual point that represents the center of the cell. So there's a dot there, there's a cell center, cell center, cell center. The cell face is the cell boundary, so it's referring to the boundaries between the cells. And then the cell face points, these are the points. I should just bring up the map actually. Here's the image from the user's manual. So we have the cell center, the cell faces, which are typically just straight lines, unless you're on a boundary here. And then the cell face points are what you may call the vertices between the cell boundaries. I bring that up because the user manual then goes on to talk about how you can make changes. Now, one obvious way to make a change is to use the break line. And we already saw that. We sketched in a break line. We can remove the break line, delete break line, and then we could just regenerate the mesh and we should see it as it was the first time. So if I go to 2D flow area, I generate the mesh, okay, yes, and okay. And then it goes back to how it was without break line. So the break lines are one way to modify the cells, but another way is to just do so manually. So you can click on edit. You can change name, of course, but now you can move points or objects, add points, and remove points. So let's go ahead and add or remove a point. As before, we were able to change the boundary of the 2D flow area. We saw that already, but now we can also change the points locations. This is the center of the cell where the water surface is going to be calculated at each time step. So I'm going to move all those cells a little bit closer. And then after I do that, if I wanted to actually save the changes, I'd go back to edit and then just make that selection again to uncheck it on move points slash objects. And as you can see, the shape of those cells changed a little bit. They used to be square just like the other ones here in the center. All right, the other edit options here is to add points. So if I wanted to add points, say I want to add a bunch of points down here because I want more precision, more detail. This C27 cell is now going to have a few more points to it. And then that's cool. So I'll click edit and then add points again. And now the center of those cells now has a bunch of more cells right near it. What used to be just one cell down here, one of the largest cells, is now about 5 or 6 different cells because of the new cell centers that I added. Also, there is edit remove points. This has an opposite effect. So let me come over here and start removing some points. I can show you what that looks like. It's going to result in larger cell size. So C22 will probably become a little bit larger. Okay, disable that. All right, yep. C13 is larger, C26 is larger, and so on. The user's manual mentions this delineate triangulation as a way to describe how this cell size works with a couple different images right here. So there's definitely more information on that if you're interested. But that is my introductory lesson on hEC-RAS, specifically the geometric data, talking about storage areas and 2D flow areas.